Trying to unpack an absolutely critical, high-stakes, microscopic rescue mission that is literally happening inside your body right now. You see, every single time you eat, a perfectly synchronized chemical factory kicks into high gear, totally hidden from your conscious mind. We're going to dive into the exact mechanisms that keep this factory humming and, frankly, prevent a daily biological disaster. Let's get started. So picture this for a second. Your stomach is basically a holding tank of highly corrosive hydrochloric acid. It's totally essential for breaking down your meals for sure, but what happens when that intense acid moves out of the heavily protected stomach and drops straight into the delicate, vulnerable environment of your small intestine? Well, if left unchecked, it would be an immediate, severe crisis. I mean, it would literally eat away at your internal tissue. No way we can let that happen. And that brings us to the exact hazard we're dealing with today, chyme. Now, chyme is the highly acidic mixture of partially digested food and hydrochloric acid that exits your stomach and enters the very first part of your small intestine. Once it leaves the stomach, this isn't just food anymore. It's a volatile, extremely low pH threat. It has to be neutralized instantly, or the whole digestion process just grinds to a painful halt. Section 1, meet the dynamic duo. To handle this acidic threat, your body deploys two incredibly specialized hormonal agents, Secretin and Cholecystokinin, which, for the sake of all of us, we will mercifully just call CCK for short. But you might be wondering, where do these agents even come from? Well, the moment that dangerous chyme hits the duodenum, which is that very first section of your small intestine right after the stomach, it trips the body's biological alarms. Hidden right within the walls of the duodenum are our command centers. You have S cells, which act as the dispatch for secretin, and right alongside them are the I cells, which release the CCK. They're essentially your body's first responders, just waiting in the intestinal walls for the chemical triggers that tell them it's time to get to work. Moving on to Section 2, complementary chemical powers, neutralization versus demolition. These two hormones, they don't step on each other's toes at all. They divide and conquer. And this brilliantly illustrates the core difference between them. Looking on the left, we have secretin. Its main trigger is that acidic chyme, and its response is deploying bicarbonate for neutralization. Think of it as putting out the fire. On the right side, we have CCK. Its trigger actually isn't the acid. Its triggers are the fats and proteins in your food, and its response? Releasing heavy-duty pancreatic enzymes and bile. If you want a really simple way to lock this into your memory, secretin equals neutralization, and CCK equals enzymes and bile. Secretin's strategy here is just fascinating. When it's released by those S cells, it acts exactly like a chemical fire extinguisher. It commands the pancreatic ducts and the bile ducts in the liver to just flood the duodenum with a massive amount of bicarbonate-rich fluid. When this bicarbonate mixes with the hydrochloric acid in the chyme, a rapid chemical reaction occurs that instantly neutralizes the acid, dramatically raising the pH. Suddenly, the duodenum transforms from this hazardous, acidic wasteland into a safe, suitable environment for the next phase of digestion. Now, while secretin is busy putting out the fire, CCK is initiating a highly coordinated demolition sequence to actually break down the food. It's a multi-pronged attack. First, it hits the pancreatic ace in our cells, telling them to dump a huge payload of digestive enzymes. Second, it literally squeezes your gallbladder like a water balloon to force stored bile out. And third, because obviously all that bile needs a clear path, it simultaneously relaxes a specific muscular valve called the sphincter of Oddi. This allows the bile to flow freely right into the duodenum where it can mix with your food. Let's look at the exact enzyme payload CCK just ordered up from the pancreas. It's incredibly specific. The pancreas deploys a targeted weapon for every single macronutrient you just ate. You've got pancreatic amylase being sent in to demolish the carbohydrates. Pancreatic lipase is deployed specifically to break apart fats. And for the proteins, the heavy hitters, trypsinogen and chymotrypsinogen, along with some other proteolytic enzymes. CCK ensures absolutely nothing goes to waste. Section 3, the 5-step process. Let's watch this entire factory in motion, unfolding chronologically. So the crucial takeaway here is seeing how one step seamlessly triggers the next. Step 1, food enters the stomach, getting mixed with that intense gastric juice. Step 2, that now dangerous acidic chyme drops into the duodenum. Step 3, the sheer acidity, the low pH, trips the S cell alarms, releasing secretin, which immediately calls in those bicarbonate fire extinguishers. Step 4, Almost exactly at the same time, the fats and proteins in that meal trip the eye cell alarms, releasing CCK to contract the gallbladder and call in the digestive enzymes. And finally, step 5, the bile emulsifies the fats, the bicarbonate neutralizes the acid, and the enzymes tear apart the carbs, fats, and proteins so you can absorb them. It is just flawless, efficient digestion. Section 4, brain and body teamwork. Neural assist. Because here is a really fascinating twist. These hormones, they don't run this factory entirely on their own. Enter the vagus nerve. While secretin and CCK are the primary hormonal regulators on the ground, your brain is actually actively participating through the parasympathetic nervous system. During this whole intestinal phase of digestion, the vagus nerve acts as a neural assist. It sends rapid-fire signals to enhance that pancreatic secretion and keep the whole digestive activity perfectly coordinated. It's a brilliant collaboration, right? The chemical hormones and the electrical nervous system working hand in hand to ensure the factory runs at absolute peak performance. Section 5, the feedback loop. Mission accomplished. Okay, so the fire is out, the food is broken down, but how does the body actually know when to stand down? The elegance of this system is that it possesses a built-in negative feedback loop. Basically, the hormones turn themselves off. As secretin's bicarbonate successfully neutralizes the acid, the overall acidity in the duodenum drops. With no more acid to trigger the S cells, secretin release just naturally stops. And the exact same thing goes for CCK. As the enzymes and bile successfully break down and remove the fats and proteins from the duodenum, the very stimuli that triggered the eye cells disappear. CCK release stops, the alarms power down, the whole factory quiets down, resets, and just waits for your next meal. To tie this all together beautifully, look at this exact quote from our source material. It captures the entire dynamic duo relationship perfectly in just one sentence. Secretin mainly promotes bicarbonate to neutralize acid, whereas CCK mainly stimulates pancreatic enzyme secretion and causes gallbladder contraction to release bile for fat digestion. That is your golden takeaway right there. 2 hormones, 2 distinct but totally complementary jobs, ensuring you don't literally burn a hole in your intestines while you extract life-sustaining nutrients from your food. It really makes you step back and marvel, doesn't it? If our bodies are running this perfectly automated, high-stakes chemical factory flawlessly, day in and day out, every single time we take a bite of food, what else are we taking for granted beneath the surface? Thank you so much for joining me for this explainer. Keep wondering, keep learning, and I'll catch you on the next one.